My name is Tyler Janetz, and this is Physics 221, video homework 5, objective saying that I can utilize a potential energy curve to determine the forces acting on and motion of a particle, giving an initial location and speed of the particle. So to satisfy this objective, I wrote this problem. A 2 kilogram ball is moving around. Given the potential energy curve below, if velocity is 0 meters per second at x equals 13, what is the speed at x equals 15? What is the force at x equals 17? What is the overall force from x equals 0 to x equals 25? And lastly, to describe the motion of the particle, determine the turning points. So this is my potential energy graph that I made with energy on the y-axis and distance in meters on the x-axis. And this is my potential energy curve here. If velocity equals 0 at x equals 13, that means k, which is half mv squared, is 0 at x equals 13 as well. So this is our total energy line, and that takes place at right here on the curve, which means that the total energy on the y-axis is 19. So going to the first question, what is the speed at x equals 15? So at x equals 15, we know that the total energy is 19. So we go to x equals 15 here. We approximate that that's about 10 joules. So the potential energy shows 10 joules, and the kinetic energy to make it up to 19 is 9 joules here. So 9 equals half mv squared. So when we plug that in, we remember it's a 2 kilogram ball for m. So 9 equals half of 2v squared. V squared equals 9 over 4, and we end up getting that the velocity equals the square root of 9 over 4. Second question, what is the force at x equals 17? Fairly simple here. At x equals 17, so we approximate that right here. It's the tangent line is flat at that point, and the slope is the change in energy over the change in x on our graph, and that equals the negative force in the x direction. So at x equals 17, the rise over run over the tangent line is 0 over 1, which is 0 newtons, making our force 0 newtons because the horizontal tangent line is tangent. Because the horizontal line is tangent to this point here. Now, continuing off of that subject, what is the overall force from x equals 0 to x equals 25? We could find that here using the same slope equation, change in E over change in x equals negative fx. So overall, this would be calculating the average force over the motion of the particle as a whole. So the change in E on our graph would be the final energy, which is 0, minus the initial energy, which is 25, over the final position, which is 25 meters, minus the initial position, which is 0, which we get negative 25 over 25, which is 1 Newton, which remember, this equation equals negative force. So our overall average force is 1 Newton. And once again, this is the average force throughout the entire motion of the ball, since we took it from x equals 0 to x equals 25. Final question, to describe the motion of the particle, determine the turning points. We remember the turning points are wherever potential energy crosses your total energy line on the graph. So with our graph, the turning point occurs at x equals approximately 6 here. And again, that's because it is the only point that crosses the total energy line. So once again, this whole equation satisfies the objective that I can utilize the potential energy curve to determine the forces acting on and motion of a particle given an initial location and speed of the particle. Once again, Tyler Janetz, Physics 221. Thank you.